Hello everyone, I am Jay Ganesh from AM Department second year. Here I am going to explain about the topic implementation of filters. Image filtering. Image filtering techniques are used to enhance and modify digital images. Also, image filters are used to blurring and noise reduction, sharpening and edge detection. Image filters are mainly used for suppressing higher and lower frequencies. Classification of image filtering. Image filtering techniques are classified into spatial domain and frequency domain. And spatial domain is classified into linear filters or non-linear filters. Spatial domain. An image can be represented in the form of a 2D matrix where each element of the matrix represents pixel intensity. The state of 2D matrices that depict the intensity distribution of an image is called spatial domain. Here we can see the example of a grayscale image in which the 2D matrix represents a pixel value of 170 of the respected region. Frequency domain. In frequency domain, methods are based on Fourier transform of an image. Roughly, the term frequency in an image tells about the rate of change of pixel values. The below diagram depicts the conversion of an image from spatial domain to frequency domain using Fourier transformation. Linear filtering. Here are some of the linear filtering such as smoothing filters, sharpening filters, and gradient filters. The smoothing filters such as Gaussian blur, averaging filtering, and median filter, which reduces noise and blur images. Sharpening filters, such as Laplacian filter, Sobel filter, and Privet filter, which enhance edges and details in images. Gradient filters, which is used for edge detection, including Sobel, Privet, and Robert filters. Nonlinear filtering. Here are some of the nonlinear filtering, such as median filter, maximum and minimum filters, and bilateral filter. Median filter replaces each pixel values with the median value of neighboring pixels, which is effective for removing salt and pepper noise. Maximum and minimum filters, which is used for replacing pixel values with the maximum or minimum value in the neighborhood, useful for morphological operations. Bilateral filter, which smooths images while preserving edges by considering both spatial closeness and intensity differences. Kernel. In image processing, a kernel, convolution matrix, or mask is a small matrix used for blurring, sharpening, embossing, edge detection, and more. This is accomplished by doing a convolution between the kernel and an image. More simply, when each pixel in the output image is a function of the nearby pixel, including itself in the input image, the kernel is that function. Operations of kernel. Here are some of the operations of kernel, such as identity, rich or edge detection, sharpen, box blur, Gaussian blur, and unsharp masking. Here is the image representation of the identity kernel with the matrix and its image representation. Here we can see the Python code implementation of image filtering. The steps involved read the test image, define the identity kernel using a 3 into 3 NumPy array. Use the filter 2D function in OpenCV to perform the linear filtering operation. Display the original and filtered image using IMShow. Save the filtered image to disk using IMWrite function. Here we can see the program code for the implementation of image filtering. First, we import the necessary library, OpenCV and NumPy. OpenCV is a popular library for computer vision tasks, while NumPy is used for numerical operations in Python. Then we define the path to the image file flowers.jpg and read the image using cv2.imreadMed function. Then we define the path to the image file flowers.jpg and then read the image using cv2.imread function, storing it in the variable image. Next, we create a 3 into 3 identity kernel using NumPy. The kernel is used for a simple image processing operation. In this case, the identity kernel will not change the image as it is essential as the same as the original image. Then we apply the identity kernel to the image using cv2.filter2d function, which performs a 2D convolution on the image with the kernel. Then the result is stored in the variable filtered image. Then we display the original image and the filtered image using cv2.imshow function. The cv2.waitKey function waits indefinitely for a key press, and cv2.destroy all windows closes all OpenCV windows when a key is pressed. Finally, we save the filtered image as filteredimage.jpg using cv2.imwrite. Here is the code explanation for the implementation of image filtering. So we can see the output for the respected code implementation. Conclusion. In this code snippet, we demonstrated how to perform image filtering using an identity kernel in Python. By applying the identity kernel, we preserve the original image without any changes. Understanding image filtering techniques like this is crucial for various image processing tasks such as noise reduction, feature extraction, and image enhancement. Thank you and have a nice day.